This is the video for 4.4, the first video. It was 3.4 in the 6th edition. So, in the last section, we talked about dividing polynomials, and in particular dividing with synthetic division. And now we're going to really see how we're going to use that. Because the whole point of this next few sections is that we find the zeros of the polynomial. And we did it before when we could factor, or if it was already factored, that's great. But if we can't factor, how do we go about doing it? Well, it really is kind of a lot of guess and check. Okay, so we kind of have to guess what one of our zeros is, divide it in, see if we're right, and if we are, then we have it partly factored, and we keep going down until we can actually factor the rest of it. So what we're going to talk about in this video and the next is how do we choose those numbers that we're guessing as zeros, right? How do we narrow it down? There are infinite numbers out there. How do we decide which one to use? So this video, we're going to talk about the rational zeros. Okay, so a rational number, remember, is a fraction, right? Anything that can be written as a fraction. So it would be the whole numbers, the negative numbers, and fractions, everything that can be written as a fraction. The irrational numbers would be like square root of 2 or square root of 3 or something like that, where we can't write it as a fraction. So right now we're going to talk about just the rational zeros. Here's a polynomial. It's written out in factored form because I want you to look at what happens here. Okay, so mainly we're going to get information from the first number when we multiply it all out, the highest degree, and the last one. Okay, so you notice that if I were multiplying this out, the very first number is going to be this times this times this times this, right? So I'm going to end up with a 2x to the 4th. Now I'm going to have all the other things in here, right? X to the 3rd, x to the 2nd, with some kind of numbers. I would have to multiply them all out and add them together and everything. But I know that the last number is going to be these numbers multiplied together, right? The constants. All right, so this is going to be 1 times negative 7 times 2, that'd be negative 14, times negative 2, that'd be positive 28. Okay, so in order to get this last number, right, I had to use, I multiplied all those numbers, and you notice that I can tell what the zeros are here, that in this one the 0 is 2, in this one the 0 is negative 2, in this one the 0 is 7, in this one the 0 is 1/2. Alright, so in all these you notice that they are factors of 28. Right? And they have to be because we multiplied them all together to get 28. And this one, the top number is a factor of 28, and the bottom number is coming from here, right? The 1/2, because we divide the 2, and that's coming from this number. So here's the rational zeros theorem. That's what it's called. The rational zeros theorem. Okay, it says that if there is a rational zero, and there isn't always, but if there is a rational zero, then it has to be made up of, it's a fraction, right? It would be this fraction, we're going to call it P over Q, where P is a factor of the constant, right? And Q is a factor of the leading coefficient. Okay, so that's the rational zeros theorem. It's going to be a fraction, P over Q, and the top number, and remember we got all those top numbers from factors of 28, and we get the bottom number from factors of the leading coefficient. So if we were going to look at the possible zeros of this one, try to move it up so I have enough room to write. Using this theorem, the factors of 28 would be 1, 2, well, let's do it this way. 1 and 28, 2 and 14, 4 and 7. Those are all the factors, but they could be plus or minus, right? They could be positive or negative. And all the factors of 2 are 1 and 2. So first we'll just list them all over 1. That would be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 7, plus or minus 14, plus or minus 28. And then we want to list them over 2. So plus or minus 1/2, plus or minus 2 over 2, but that would just be 1, so we don't want to repeat that. And 4 over 2, but that would just be 2. And we got plus or minus 7 over 2. And 14 over 2 would be 7, and 28 over 2 would be 14. So that's it. Okay, here are our possible zeros for a polynomial that begins with the 2x to the whatever the leading degree is and ends with a 28. The rational zeros would have to be these. Now, that still seems like a lot, but let's see, we have 1, 2, 3, 4, 5, 6, 7, 8. There's 16, right, with the positive and negative. And 16 seems like a lot less than infinite, right? When we're looking at, oh, it could be anything, it could be any number, or we're looking at, it's one of these 16 numbers, or maybe several of them, right? That's what we would be starting our search using these. All right, here's another polynomial. So you notice that the leading coefficient is 1, right? So that means that we're only going to have to divide by 1, which means we don't have to make it a fraction at all. It means all of our rational zeros for this are going to be integers, right? Could be positive or negative. So let's look at the factors of 20. And I just like to do them in pairs. That way I can make sure I've got them all, right? So 1 and 20, 2 and 10, and I just go up. 3 doesn't go into it, right? 4 and 5. When I'm meeting here, right? So my next number would be 5, and that's already there. I know I'm done. There can't be anything bigger than 5 that I don't already have listed, or else there would be a matching number less than 5. So this is it. We got 6. we could list them. We need to make sure they're plus or minus. 1 plus or minus 2 plus or minus 4 plus or minus 5 plus or minus 10 plus or minus 20. Okay, so if I ask you to list all the possible numbers, these would be them. Okay? In the quiz, when I have you list them, you're going to have to list them separate with the plus and the minus. Because we don't have a symbol for a plus and minus to enter something into the quiz. I won't make quite so many. Okay, so what do we do with these? Well, we just start trying them out to see whether or not they're a 0, right? So we'll start with the easiest ones, right? I'll start with 1. And 1, -1, -16, -20. Alright, so bring down the 1. I multiply. I get 0. I get -16. And obviously, this is not, 1 is not a 0. Alright, so, well, let's try -1. Okay, so that would be -1, that would be -2, that would be 2, -14, that would be 14, that would be -6. So, -1 is not a 0. You don't have to start with 1s. Let's try 2. That'd be 1. I'm just multiplying and then adding. That didn't work. Let's try -2. -3, that'd be 6, -10. Oh, that'd be +20 and 0. Okay, so yeah, I found a 0. -2 is one of my zeros. Now what I have left is a quadratic. It's x squared minus 3x minus 10. And I think I can factor that. So I would have x, and I'm going to do 5 and 2, so it'd be -5, +2, and I already have the x plus 2. Alright, so there's my polynomial factored, right? And that means that I've got a 0 at -2 with multiplicity of 2, and I have a 0 at 5 with multiplicity of 1. Okay, so that's the idea of what we're doing, is we're finding all of these zeros, and we narrow it down by seeing what numbers up here we could use. You notice that I would not have tried 3. 3 was not on my list. So I would not have tried 6. These are the only numbers I would try. Here's your quiz problem. I want you to make a list of all the possible rational zeros. Okay, I don't have a symbol for plus or minus without going into LaTeX, so I just want you to list them out. There are only 8, even if you list the positive and the negative separately. And some of them will be fractions, so write your fractions in a line, like 1/3 if you had a 1/3, or 1/2 if you had a 1/2. Okay? And write them into the answer in Canvas.